Yeah, thank you, everyone. My name is Remco Sprooten, but most people have trouble pronouncing that. So in most countries, I just introduce myself as Bob. That's easier for everyone. Yes, indeed, we will have a bunch of demos today. So if there's anyone in the audience you don't like, please let me know now so we can sacrifice someone to the demo gods. That's always helpful. No, in all seriousness, I have some demos. I'll try to keep it short because we only have 25 minutes. I will be here during the rest of the day, so if we don't manage to get to any Q&A, just come up to me and ask. Let's start with a little bit of background. The reason that I started the project around this talk was actually because of a project that we presented at Virus Bulletin a couple of weeks ago. Me and a colleague, Ruben, are both very interested in Linux malware. So at some point we decided it's about time that we look into that more because there's way too much Linux malware going around and way too little attention. It's really under-researched. Just to name an example, if anyone has like a paid subscription to VirusTotal, you can search for content for malware samples. The easiest way to find 85% of Linux rootkits is by searching VirusTotal for the word rootkit. It's actually in there most of the time. It's that stupidly simple to find. So we set out to start investigate what is the current state of Linux rootkits in the world. We decided on some metrics and some things we wanted to investigate. And as one does, 1 week into the research, we decide, hey, this is a good idea. Let's submit it to a bunch of conferences and see what happens. Of course, a month later, you get an acceptance email and then think, oh, shit, now we actually have to do the research. What I haven't mentioned is that both Ruben and myself are a little bit of overachievers. I have ADHD brain, so stuff goes exploding all the time, everywhere. So we started out with, let's investigate the top 10 most used Linux rootkits. That became the top 20, the top 30, the top 40. Of course, every sample has multiple variants, so multiple versions and updates. And before you knew it, I was looking at a batch of like 300 samples that I needed to reverse engineer for this research. And we got an acceptance email, and we need to submit a paper within like 2 months. Yeah, that's not going to happen. Now, normally when I reverse engineer a sample, it takes me between 4, maybe 8 hours to really like clean up the sample in my disassembler, get some know-how about what it's actually doing. Now, multiply that by 300, and you can figure out that that's not going to happen. Now, in the time that we started this, there was a lot of talk around using something called MCP, the Model Context Protocol, in combination with disassemblers, and people started playing around with that. Now, what is MCP? The Model Context Protocol is basically a protocol that is used or developed so that a LLM, ChatGPT, Gemini, Grok, whatever you want, is able to use real-world tools and context in their execution. Here is a very, very simple example, and I understand that not everyone might be able to read it, but here you see a simple MCP server that allows the LLM to do a addition. Very simple, but it gets the message across, of course. I won't use this example for too long, but you have to remember MCP, it's still kind of new and people were experimenting with it. So one thing they really didn't take into account, and I'll come back to that really at the end of the talk, is the amount of context that you add to the LLM, the amount of overhead that you generate. What you see here is a normal message which you would normally send to ChatGPT if you're like typing into a web prompt. You have a system message where you tell the LLM, hey, this is the role that you're performing, and you have the human input. Please explain this code sample, for example. Now, if I add some tools to via MCP to that conversation, the request looks like this. you tell the LLM, hey, I'm giving you a function. The function allows you to decompile something. I describe that function, and for every function and every tool that I give to the LLM, the API request becomes significantly bigger. This is a very powerful tool, but you will see why the size of this request might become an issue at some point. Now, come on. Now, I've set up a sort of a workflow, and step back. I'm still like in the process of reverse engineering 300 samples. So what I did is I took my laptop, I wrote a small MCP server using Python. I used the disassembler. My favorite one, Binary Ninja, and Binary Ninja is great for those in the reverse engineering world. Yes, I know IDA is like the de facto standard. I dislike IDA. I really don't like the product. Binary Ninja has like an amazing, easy-to-use API, so it was really easy for me to write up the plugin that I need to do this. Now, what I did, I have my LLM client. I used raw code. I used bunch of stuff, but I'll show you that in a second. The LLM client will talk to a MCP bridge, so a program that will translate MCP into stuff that Binary Ninja will understand, and that's talking via HTTP to a disassembler. Why via HTTP? Because I actually thought of the fact that, hey, these 300 samples are going to need an actual workflow, so I might need to put this disassembler somewhere on a machine that does stuff headlessly somewhere. Well, just to keep things fair, people have written multiple MCP servers for all the disassemblers. If you're a fan of IDA or even Ghidra, I don't know why, but if you're a fan of that, then please check out these projects. I also mentioned I'm using an LLM client. In order to talk to an LLM via the actual API, you either need a client or write the code up yourself. Now, I'm quite lazy, so I prefer to use anything that is already built. Today, in the demonstration, I'll be using Cursor, but I also have good experiences with raw code. There are way more clients, but I haven't used them, so I can't recommend them. And that becomes demo time. Let's see. Did someone sacrifice anyone yet? In that case, be strong. Well, what you see here on the left, Binary Ninja, just a normal interface. I've already set in the, because we're limited in time, I've already set up in the background the connection between the LLM client and Binary Ninja. You just have to believe me that that is what is happening here. And on the left, there's a Linux rootkit that is loaded. It's slightly obfuscated. And normally, my job is to, okay, let's figure out what does this function do? What does this function do? What does this function do? And then rename all the functions. Now, because I'm unable to actually type something when people are looking, I'll copy and paste the prompt that I asked. And I'm just going to tell the LLM, reverse this binary, figure it out, be fast. Because of time, you know. Now, in this case, I'm using Claude, and Claude is actually amazing at doing this stuff. It'll figure out, hey, I've got a MCP server, because the API request that I send it will include like all the functions that the MCP server provides, and it'll start working on it. Now, I told it would be fast. Of course, it won't do that. But if you can actually look at what it's doing right here, you can see every request that's being made, and it's trying to figure out what this file is. Now, give it a minute or two, and at that point, it should present us with an outcome. Now, I know it's hard to read, but it already figured out, hey, this is a rootkit. It's really trying its best to like reverse engineer it and figure out what it's doing. Now, I actually do know what it's doing. I cheated a little bit. The rootkit here is one that I actually wrote myself. So, but it's slightly obfuscated, so that makes it quite hard for an LLM to figure out what is happening. But as you can see now, it is confirmed this is malware. Now, another thing is, this report, it's great, but to me, this is absolutely useless. Why? Because I can spin through 300 of these reports, but for the research, I was actually looking for what syscalls are being used. How does the binary actually look like? What functions are used? What is the difference between multiple versions? So the prompt that I gave it, let's be honest, is basically reverse this malware. It's the same as a manager coming up to me, slapping me in the face and saying, hey, reverse, 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 do it, you know? It's kind of rude, and I know we're not supposed to consider these LLMs humans, but in some aspects, they are a little bit like that. Now, let's try again. And now let's give it a more specific prompt. Again, I can't type while you're looking, so. Now, this prompt, I'm asking it to actually rename the functions. And hopefully, if the demo gods are smiling upon me, we will see on the left that at some point, some of these functions might get renamed. And what that does is it actually ends up giving me a database that I, as an analyst, can actually look at and extract information that I need. I'll just let it run in the background, but on average, this saved me going through all the samples. Instead of doing 4 to 8 hours, it's now, once the LLM has done the initial work, it'll only cost me 1 hour per sample. Now, 300 hours to go through all the samples is still a lot, but it's way better than trying to figure out it all by myself. This, however, is not free. For every prompt that you see going up there, my employer is paying AWS Bedrock in this case. And we will talk about the costs in a little bit. But as you can see now, if you can actually read it, I hope so, it figured out like, hey, this function is doing XOR decoding, this function is invoking the kprobe handler, process hooking call. Even though it is slightly obfuscated, the LLM is able to figure out what this binary is doing. It's also asked it like, hey, give me some comments. So for every function that it encountered, it'll add a comment so that if I look at the database later, it'll figure out that I can read whatever is happening here. Now, let's waste money on the background. Hey, I'm not paying for it. Now, one thing I did halfway into running through all the samples is, well, actually I didn't. Anthropic released Claude 4.5. I was using Claude 4.0, and me as a tech boy, I went on to like, hey, new version, let's use this, let's upgrade. We've switched to 4.5, and I was actually getting better reversing results, but not completely the same. Now, the thing is, and for this, let's go a little bit back to the slides. Is there anyone in the room that actually understands AI models? If so, I'm so sorry for what I'm about to do, but I'm oversimplifying the process. This is an AI model. Basically, you feed it a number, that number gets thrown into a network, and all the nodes in the network will do a computation based on the numbers that we put in there. And the output is hopefully the number that we want as an output. Now, how do we actually generate this model? We basically start by choosing random numbers, see if the input and the output is what we want, and if not, we throw it away and try again, and try again, and try again, and try again. And we keep trying until we finally find one model that will give us the output that we expect. Now, the thing is, if you go from model version 4.4.5, they will have given the model more information, trained it again, but and the model will be smarter. However, it's a different model. The decision tree is slightly different. These numbers are slightly different. And again, I shouldn't compare this to a human, but think of it as the personality of the model has changed a little bit. So the way that you ask the question can change slightly. In my case, some things that for Claude 4.0 were what was doing out of the box, I had to like specify for Claude 4.5 in terms of please don't output this or please add this in the output. So the context engineering or the prompt engineering changed a little bit. My lesson learned here was if you work with models and you have a prompt ready for this model, there's no guarantee that it will actually do exactly the same on like a new version of even the same model. But we can do better. As I said, I expected that I want to run these files in batches, so we started using N8N to automate everything. And I know I'm running late on time, so please forgive me if I'm rushing a little bit. What I did, the same setup that I had, I've put into a N8N framework. For those who haven't used N8N, it's a application where you can visually put together building blocks, connect the multiple APIs together, and have it work quite automatically. So basically, the only thing that I changed was instead of an LLM client, I'm now using N8N, and it's still communicating to Binary Ninja. Binary Ninja is now running headless in the cloud somewhere. And this is how the setup will look like. Let's show that live. And there is basically it's a slightly different sample, but it's just the same as what I did right in Cortex. There's a system message. I'm telling it exactly what it needs to do. And if we run this, you will see that it'll start working, and you can see what it's doing over here. Now, every request that's being made is a list item here. And if you notice something, the request that I'm making is, and every time that I'm doing it, is getting bigger and bigger and bigger. Now, why is that? LLMs do not have a memory. The only memory that an LLM actually has is whatever you send it at that time. So if you wanted to remember that, oh, you already reversed this function, you need to send the entire chat over to the LLM again. Now, LLMs aren't that expensive. We're talking things get translated into tokens. So here you can see the amount of tokens that get used for a request. And here you see the total tokens that are being used for this conversation. Now we're talking about 0.3 cents for 1,000 tokens that you pay. The thing is, I'm using 250,000 tokens for this conversation, and it's not done. I know from experience that you should not load up a huge Golang binary and go get lunch. It is quite possible to go into the tens, maybe hundreds, maybe thousands of dollars if you just have this run and run and run and run. Yes, you will at some point reach the point where the maximum context window is used, but if you make a config error, you will just keep sending 200,000 tokens in and just keep doing that until the end of time. And as I said, I'm not paying for it, luckily, but we're now up to 500,000 tokens, so I already wasted like $1.50 just by talking to you. Stop this. So let's stop this for a second. Now, this was all good, but I'm basically getting the same result. And remember, this is still my manager coming up to me, slapping me in the face, saying reverse. We can do better. So for that, 5 minutes. For that, if I normally start looking at a binary, I will get some more information. I will check virus total. I will send this sample into a sandbox. I will do stuff to get more information before I just open a disassembler. And thinking about that, maybe the LLM can use some external information as well. So what I did here is a second version of the workflow that instead of just sending it to the reverse engineer and the last node here is the reverse engineer. I'm first getting some information from VirusTotal. I'm getting some information from our sandbox internal and feeding that into a model. But if you ever worked with VirusTotal, you know that the reports that VirusTotal produces, and I'll show you one here, will contain a lot of information. It is like very, very huge. One thing you also have to know is that LLMs get overwhelmed quite fast. So if you give it way too much information, it'll start making stupid decisions. So what I'm doing here is, before I send it to my reverse engineer, I have another LLM summarize the entire stream that I get from VirusTotal, then feed that to my reverse engineer, and in the output, the reverse engineer can actually figure out, hey, I'm talking about, I know it's down there, but it's, I'm talking about this kind of malware, and it has some more information. It can actually produce some useful output. Now, the last thing that I want to show you, and then I'm almost out of time, is another version, and that's getting even more complex. I've run this execution before we started, just in the interest of time. We as engineers, we've been like reverse engineering malware for years. And we produced IDA databases, Ghidra databases, and binary danger databases with like marked up code samples for every kind of virus that we investigated. And if I sit down and I investigate a sample of a family that I know that I already investigated, I'm not going to start by going through the sample all over again. I'm going to open my own my previous database. So that's what I did here as well. I gave the LLM access to a code similarity search. And how is that set up? I basically set up a vector search database with all kind of code samples from databases that we already have reverse engineered. And now the LLM, in this example, will basically... come on. Let me find a decent example here. Here. Zoom in so you can actually see it. The main LLM will actually send over a code sample, so just compressed, doesn't even matter what's happening there. And in response, it will get an answer. Hey, I already found this function inside the database. It's part of the warm cookie malware. And it will then feed that back to the main LLM. Just as a normal analyst, it can then look at the code, say, okay, hey, I've seen this before. I can rename this function and make it more efficient. Now, wrapping up. This was like the final setup. So instead of Anidan just having access to Binary Ninja, I'm now giving it access to a RAG and a vector database and other setups or other sources of information, and that improves the analysis. However, it does use a lot of tokens. Now, we did figure out you can reduce the amount of tokens by doing multiple passes. Instead of giving it like the entire binary in code and then asking it to reverse engineer it, you can first ask it, hey, do the first 5 functions, reverse engineer that, stop. Then ask in the second LLM in the second pass, hey, focus on this function and stop sending over the whole conversation over and over again. And a few lessons learned. Prompts are model specific. LLMs get easily overwhelmed, as humans do, but if you give it too many tools, too many information. As with all AI projects, quality of input matters. Shit in means shit out. So if you give it bad information, it will make bad decisions. And LLMs can get really expensive. So if you start a LLM-based project, make sure that you preemptively consider the cost of the thing that you're doing, because a few cents per token translates into a lot of dollars if you go into the millions and tens of millions of tokens. Thank you.
Thank you for the talk. I'm sure we have a lot of questions. Just looking in the audience, one up front and back to the here. What do you have to catch?
Oh, there you go.
I think you probably have this obvious question all the time, but why Binary Ninja over Ida and Ghidra?
This question I can spend 2 hours on. No, Ghidra, have you ever opened it?
I've used
Yeah.
both.
Well, need I say more? If you looked at it, then no, the interface is just not made for humans. Binary Ninja is, especially after like version 4, started at a level of decompilation where it's a huge competitor for IDA at 20% of the price. So just for that, it's my reason to stick with them. And if you see the improvements in their API, the Rust API that they provided now, and I'm not paid by Binary Ninja, by the way, but I just love that project. I've been using it since open source, and yeah, you won't get me back to IDA anytime soon.
Thank you.
Okay. I think we have time for one more question back in the middle.
While we're standing over the microphone, again, I will be here. I'm open to people coming up to me, so if you have questions, just hit me.
Thank you for the presentation. One question: how much did the LLM hallucinate results? And did you have any point where you took a look at it in Binary Ninja and thought, yeah, maybe the function name it was given, yeah, that's not what happened, or anything like that?
Yeah, of course that happened. But to be honest, while using Claude 4.5, it was kind of rare to find it hallucinating. I will say I used it a lot for Linux reverse engineering, and as I mentioned in the beginning, Linux is very under-researched, so the malware is rather simple. There are really complex Windows samples that are considered where more hallucination is happening. In Linux samples, it's quite obvious what is happening, so I wouldn't say that there's any really part. No.
Okay, thank you.
Okay, thank you. Then thank you. Another round of applause for Remco.
Thank you.